deriving the equation for kinetic energy from the definition of work. There's an equation that relates the energy an object has due to its height. Its gravitational potential energy is related to the height in this way. Likewise, there's an equation that relates the elastic potential energy in an elastic material, in an ideal spring specifically, relates that energy to the stretch of the spring. So it only makes sense that there's an equation that relates energy, kinetic energy that an object has due to its motion, to the velocity of the object. So there must be a relationship between the energy stored as motion of an object and the velocity of that object. To do so, let's consider a free fall situation, starting from rest, that allows us to use the concept of work in which a force acting on an object is the gravitational force, pulling the object a distance down to the ground that's equal to the object's height above the zero level. So we'll have a force, and it'll be operating over a distance, so work will be getting done, and it'll be the work done by the gravitational force. So we have the idea of work as a start, and we will bring in the motion of the object, in this case free fall, using Newton's second law, where the net force, which will be the lone force of gravity pulling down on the object, that's net force here, I don't have sigma, equals the mass of the object times the acceleration, which would be the free fall acceleration of 9.8 meters per second squared in this case, but that's not important. We'll just use the symbol A. So an object with a mass m is released, it's in free fall. Gravitational force is the only force acting. As it falls to the ground, it will act over the distance d, which is equal to the height that the object starts at, and it has the acceleration a. So starting with the familiar concept of work, we'll substitute in the appropriate terms here. The force is the force of gravity, and the distance d that force will work over is h, the height, which gives us this expression for this circumstance. But we know that the gravitational force also equals mass times acceleration. In this case, that is the net force, and this gets us to connect the motion of the object into this analysis. So I will substitute the mass times acceleration in for gravitational force, leaving us with this expression for a moment. Now the hunch here is that the energy is related to not the acceleration of the object, but the velocity. So using some kinematics, we'll substitute in for this acceleration. So you'll recognize this kinematic equation. But since this object is starting from rest, this term here, v0 squared, will be 0, leaving us with just this expression here. And I want to solve that for acceleration, so I can substitute it in, which is easy to see, is acceleration is equal to the square of the velocity divided by 2x, x being the distance that the object is traveling. In this case, that is really h, the height. So we have this expression for acceleration that we'll substitute into the equation on top. And that gives us this expression. And you have to look carefully, but this quantity here is multiplied by h, and down in the denominator of this ratio is an h. So this h outside will really cancel the h inside, so this expression simplifies to this expression here after canceling out the h for height, and this can be rearranged to give this equation. Work done by the force of gravity on this free-falling object is equal to 1/2 times the product of the mass of the object times its velocity squared, and that would be the velocity at any point in its fall. That would be how much work had been done up to that point. But we know that work is the transfer of energy, so the gravitational potential energy is becoming kinetic energy. So this work here can be called kinetic energy. leaving us with this expression. And there it is. Kinetic energy equals 1/2 the product mass times the velocity of the object squared. We have a relationship between the energy stored as the motion of the object and the velocity, which is what we were looking for. And it all started based on the idea of work, in this case work being done by the gravitational force over the distance, which was the height of the object. And we also brought in Newton's second law for a free-falling object, and this was the result of that combination, this expression for kinetic energy.